All right, everybody, section 2.10, inverses of exponential functions. We're going to explore at the beginning of this video what happens when we take an exponential function, so something in a times b to the x form, and we find its inverse. And so we learned, I believe it was section 2.8, that to find the inverse of an equation, we just start by swapping the x and the y. So y becomes x, and x becomes y. Then we solve for y. The issue now is that we have y in the exponent, and so to solve this equation here, to find the inverse of that original exponential function, we're going to have to introduce a log somewhere in this equation. So to do that, we write the word log. The base of the exponent becomes the base of the log, 2. And then what was with the base is going to switch. So y was with the base, but now x is going to be with the base. And it's going to equal that y right there. All right, so here's what that tells us. That if we take an exponential function or graph and we find its inverse is just a log graph. All right, so that's our takeaway from this, that log graphs are the inverse of an exponential graph. So let's say we have an exponential function like y equals 2 to the x. All right, I've got some key points listed on this graph. So we have 0, 1, we have 1, 2, and we have 2, 4. If we were to take the inverse, so to turn it into a log graph, all we have to do is swap our x and our y's. So 0, 1 would become 1, 0. 1, 2 becomes 2, 1. And then 2, 4 becomes 4, 2. Now, notice this portion over here that's approaching the x-axis, and it's the negative portion of the x-axis. After we connect these points, we're going to have this graph approach the negative y part of or the negative portion of the y-axis, I should say. All right, and so this is what all log graphs are going to look like as long as the base is bigger than 1. All right, before transformations, they're going to look like this. Just like exponential growth is going to approach the negative x, logarithmic graphs approach the negative y-axis. All right, these are actually just reflections over that line right there, y equals x, to get the inverse function. All right, so again, takeaway from this, this is what our log graphs are going to look like right here. They're going to pass through 1, 0, they're going to approach the negative y-axis, and they're going to curve this way. Now, one more point to make before we move on. So with exponential functions, the y values are changing by multiplication, right? So 1 becomes 2, 2 becomes 4 because we're multiplying by 2. With log graphs, it's the x values that are going to be proportional. Not bringing out of space, proportional, and I'll just move that so it looks a little bit better. Right there. The x values are proportional, not the y values anymore. So the x values are changing by multiplication. All right, so now we have 4 tables, and we're going to try to identify whether these are linear, quadratic, exponential, or logarithmic. Okay? So what I always look for first is multiplication. So with exponential, it's the y's that are being multiplied. With logarithmic, we just learned that it's the x's that are being multiplied. The x's are proportional. So I'm going to look at these and see which of these are changing by multiplication, and is it the x or the y? So our first table here, it's the x's that are changing by multiplication. We're multiplying by 3. So if it's the x's that are changing by multiplication, so that first table will then be logarithmic. The second table, so let's see, the x's, we're just adding 2. But the y's, they're being divided by 2, or in other words, times 1/2. So even though it's exponential to k, it's getting smaller, this is still an exponential function because the y's are being multiplied here. All right, that looks like the only 2 where any of the values are changing by multiplication. So for linear quadratic, a linear function, the first differences are going to be constant, and a quadratic, the second differences are going to be constant. So let's see this one. The x's are increasing by the same amount, but the y's are +1, and then they're +3, and then +5. So because those are different, it's not linear, but the second differences are +2 and +2. So that would give us a quadratic function here. All right, then our last function. So the x's are all increasing by 1, and the y's are decreasing by 2. So because these numbers are the same, the first differences are the same, that would give us a linear function. All right, we got 2 more questions. Both of them are going to be pretty similar, but it says this: find the inverse of this logarithmic function. So again, this is going back to that section 2.8 where we have to swap x and y and then solve for y. So we're going to replace f of x with x, and we're going to replace x with y. Now, to get y by itself, we're going to have to get rid of that 2 and somehow get rid of that log. So because the 2 is outside, I'm going to move that over first. To undo the multiplication of 2, we're going to divide both sides by 2. Cancel those 2's out. So that gives us x divided by 2 is equal to the log of y. Now, to get y out from inside this log, we're going to have to convert from log form into exponential form. So remember, if it spells the word log without a base, it's a base of 10. So in exponential form, the base of our exponent is going to be 10. The y is not going to be with the 10 anymore. The x over 2 is going to be with the 10 as the exponent. So x over 2 equals, and then the y is on the opposite side of the equal sign here, so equals y. All right? So this would be the inverse, which we should expect that the inverse of a log function with the base of 10 is going to be an exponential function with the base of 10. All right, really it's just figuring out what is in the exponent from there. All right, so that's the answer to that one. And then one more, but this time it's an exponential function. So to get the inverse of this, again, replace g of x with x, and replace x with y. Now, all of this is inside the exponent. All right, so because the exponential portion is by itself, we're going to go ahead and convert this into a log. All right, so our log is going to have a base of e, and then the y plus 2 was with e, but now it's the x that's going to be with e, and it's going to equal the y plus 2 goes to the other side. All right, so again, I just converted from exponential form into log form, and then we can replace the log base e. That's really just a natural log. All right, last step, get y by itself. We're going to subtract that 2 over, but be careful, it's not with the x. I'm going to put parentheses here to show it's not part of the natural log. All right, so this would be our inverse function right here. And again, we should expect that if we have an exponential function with a base of e, its inverse is going to involve a natural log. All right, in this case, that minus 2 ended up on the outside because it started on the inside here. Whereas on this one, it was on the outside, so we divided it over first, and it ended up in the exponent because of that. All right, so if a number's outside of a log or an exponent, it gets moved over first. If it's inside the log or the exponent, after we convert, then that number gets moved over. All right, that's it for this one, guys. Stay flawless.